All right, let's go ahead and solve a couple logarithmic equations. So as we do this, we want to make sure that first of all, we have our logarithm is on one side all by itself. And if we have any constants, go ahead and put those on the other side. Both of these have already kind of been worked out that way for us to begin. Next thing what we're going to do is use this definition of a logarithmic function in the middle in the red box. So to use it, what I like to do is we're in logarithmic form right now. We're going to switch over to exponential form and then hopefully be able to solve the resulting equation. So to get started, I'm going to go ahead and identify whatever our base is. That's the subscript that goes along here underneath the log. So in our first one here, the subscript is a 5. So that's going to be the base when we switch over to our exponential form. Now this kind of looks like 5 raised to the 4x plus 5 power. It's not really what it means, but that's what it kind of looks like. So when we switch over to exponential form, we're going to use the 2 from the other side as our exponent. So it's going to be 5 to the second power equals what remains is what was inside the logarithm. So 4x plus 5 goes on the other side. So this equation we got to actually shouldn't be too bad, right? 5 squared is the same thing as 25 equals 4x plus 5, just bringing that along. Now this is a linear equation, so we'll go ahead and get all the variables are on the right side. We'll move the 5 to the other side, so all of our constants are on the other side. 25 minus 5 makes 20 is equal to 4x. And again, 5 minus 5 makes 0 on that right-hand side. And to wrap this up, we're going to get rid of the 4 by dividing both sides by 4. So x should equal 5 in this case. Now we could double check by plugging back in just to double check. 4 times 5 gets plugged in for our x plus 5. Work out to be 20 plus 5 is 25 on the inside here. We can't have a negative overall result on the inside of that logarithmic function. So positive 25 is just fine. Next, let's go to the problem on the right-hand side. So on this one, we can't see a base. It's not identified here. So we have to understand and remember that when we don't identify the base, that's a common logarithm, and it's automatically base 10. So we're going to start out with that base, 10 raised to whatever's on the other side, so 10 to the first power equals x plus 1. Works out to be a very easy equation because 10 to the first is just 10. We'll need to subtract the 1 to move it to the other side, and we end up with 10 minus 1 makes 9. X on the right-hand side is these 1s, positive 1 and negative 1 makes 0. And maybe double check here at the end just to make sure. We take our 9, we add 1, that's going to be a positive 10 overall on the inside of that log. So it's positive value that works with our domain of logarithmic functions, and that's our solution, x equals 9. Hope this helps out. Good luck.